Dr. K. Parinivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Welcome to the lecture series on chemistry of environment. We are discussing about atmospheric chemistry. We discussed the air pollution episodes, air pollutants, different type of air pollutants, and the source, health effects, etc. we have seen. And to finally in this series on atmospheric chemistry, we are going to discuss about air quality standard and how to determine the important air pollutants and finally to control this. If you see the air quality standard, different countries have different standard. Okay. And India, we had earlier air quality standard, and in fact now it is modified. From as of 2009, we have this current air quality standards in force. If you see this air quality standard, earlier our Indian standard have 3 group. One is residential, industrial, and ecologically sensitive areas. Now in this recent amendment, 10 years back it happened, it is converted into 2 group. One is industrial and residential area mixed, the other one is ecologically sensitive area. This is a standard for ambient air quality apart from the industrial stack, that is the industry specific standards we have. This is for national level ambient air quality standard. Okay. If you look at the standard, this table gives you the what are the pollutants actually regulated and what are the time duration, what are the value depending on the zone where it is, whether it is a industry, residential or ecologically sensitive area, and the method of measurement, everything is given. If you see the nature of pollutants listed here, it covers both the toxic sulfur dioxide, oxides of nitrogen and carbon monoxide, particulate matter, 2 size with a 10 and 2.5. We have apart from that ozone, ammonia, and including aromatic compounds like benzene, benzpyrene, and heavy metals like lead, arsenic, nickel, etc. And if you see the standard, there are 2 varieties. One is measured for 24 hours one, the other one is annual average. Both we have different standards. If you see the for sulfur dioxide, the annual average should not exceed 50 microgram per meter cube, and for ecologically sensitive area like health resort and hospital area, it should be 20 microgram per meter cube. It should not be exceed this value, the annual average. Whereas 24 hours standard, it is slightly liberal, it is 80 microgram and both this area if it is 24 hours exposure. Okay. And if you see the method of measurement for this sulfur dioxide, the standard also give the method of measurement, and for sulfur dioxide 2 methods are listed. One is it is a improved West and Geikie method, the other one is UV fluorescence method. So, there are 2 methods available. The UV fluorescence method is a continuous monitoring method, whereas the improved West and Geikie method, where the sulfur dioxide has to be fixed on the site, bring it to the laboratory and then develop color and measured by spectrophotometric method. That is the first method. This is a manual method, somewhat time consuming, whereas the UV fluorescence is a continuous method, immediate reading you can get it. The UV fluorescence, sulfur dioxide is exposed to UV light, sulfur dioxide absorb and emit fluorescence, the emitted fluorescence is measured, and usually these instruments, UV fluorescence instruments, are calibrated with a permeation device with a known standard and then used. Whereas in the improved Western Geikie method, normally the samples are fixed on the site. For fixing, there are two types of solutions used, tetrachloromercurate and other one is formaldehyde can be used for fixing, then bring it to the laboratory, treat it with a dye and measure the color spectrophotometrically. This is a method thing. Both the methods are very useful to determine ppm level or below level of sulfur dioxide present in air. The other pollutant is oxides of nitrogen. The value annual average should not exceed for NO2 as 40 microgram per meter cube. This ecologically sensitive area, it is 30, whereas 24 hours, that is a short term, that is 80 microgram in both the places, whether it is industrial, rural or ecologically it is 80. The method of measurement used again here for this measurement, there are two methods mentioned. One is chemiluminescence, which is a continuous method on the site. The other method is similar to sulfur dioxide, fix the sulfur dioxide on the site, bring it to the laboratory and then measure color. The chemiluminescence, the oxides of nitrogen is reacted with ozone and which will emit, the product will emit chemiluminescence, the intensity is measured. Whereas in the manual method, alkaline sodium arsenite is used as a fixing agent, that is alkaline medium is used to fix this acidic nitrogen oxide and that is fixed as a nitride, bring it to the laboratory and then develop color by reacting with azodine, okay, that will develop give you a very nice color, violet red color, that is measured in the laboratory manually, and both the methods are useful to determine this concentration below this range. Coming to particulate matter, these are the another two parameters in this particulate. As I mentioned before, size is very important, because that is the especially a respirable particle is one causing a lot of health issue. So, it is very important to distinguish the particle size. Particulate matter with a 10 size, less than 10 micron, and another one is particulate matter with less than 2.5 micrometer size. Okay. Both are monitored nowadays in India. Earlier standard we measured as a particulate matter, and for particulate matter 10 annual average for industrial area and residential 60 microgram per meter cube and no relaxation, and ecologically it is also 60. Whereas for 24 hours it should not exceed 100 microgram per meter cube, both the places particulate matter. And the method employed are gravimetric method, total oscillating electron microscope, or a radioactive based beta attenuation method, which is a continuous monitoring of particulate matter. Okay. And gravimetric is a manual method in which you have to using high volume sampler, that dust has to be collected on a filter paper, glass fiber filter paper, the empty weight is known, and after making dust collection either for 24 hours or usually 8 hours, the paper is brought to the laboratory and then the empty weight plus gained weight is measured. The gained weight is actually proportional to particulate matter 10 with a proper head selection. This is done, and same method is used for 2.5 gravimetric or beta attenuation. Continuous method can be used. Gravimetric is a manual, and the head selection with a less than 2.5 is used. So, by putting a different head we can collect either 10 or 2.5, and the standard for 2.5 is 40 microgram in both the places, and 24 hours average should not exceed 60 microgram per normal meter cube. Same thing for ecologically sensitive area. So, these are the parameters routinely monitored by our pollution control board across India and different states. Other pollutants monitored by pollution control board and for other things also, the standard is carbon monoxide. 1 hour as value should not exceed 4 meter cube per meter cube in both the places. The technique used is carbon monoxide technique used is NDIR method, non-dispersive infrared spectroscopy is used to measure this continuously on the spot, in which the NDIR is one technique. Usually spectroscopic technique goes for splitting of light IR to select a particular wavelength. Usually you split the spectrum of the one to select appropriate wavelength and do this, whereas in the case of carbon monoxide it is a technique called non-dispersive. The light are not dispersed, as such it is allowed to fall on the carbon monoxide which is activated and then emit heat. As I told you before, these carbon monoxide is a IR active compound. Any IR active compound absorb IR light, convert this light into heat energy. This is what we discussed about greenhouse effect or global warming. Any compound which is a heteronuclear compound has the ability to absorb IR light, capture IR light and convert that into heat, and that is used for its determination. So, similarly here the carbon monoxide NDIR technique is used for its determination. It is a heat based technique is the one. Ozone, again it can be monitored for 8 hours, 1 hour and 24 hours, and the standard behave accordingly. For 8 hours it is 100, for 1 hour it is 180, and for 24 hours it is 60. So, depending on the time we have different standard, and the method recommended for measurement is photometric color thing or chemiluminescence or chemical method can be used for thing. I mentioned about nitrogen dioxide measurement, in which chemiluminescence is one of the method, where in which ozone is used as a reagent, whereas here in the ozone determination NO is used as a reagent here. So, both method are same, chemiluminescence method, or ozone is a very good oxidizing agent. It may react with the iodide and liberate iodine, that can be used for determination of photometric method, color measurement. So, these are the method used for determining ozone in the troposphere lower part. Another pollutant controlled in air is ammonia. Certain industries or anaerobic condition may emanate ammonia, and that has to be monitored, and again annual average and 24 hours, either 100 microgram or 400 is a standard for annual and 24 hours standard. The method used are chemiluminescence or indophenol method can be used for, both are manual method. Indophenol blue method can be used for spectrophotometric method. Ammonia can react with this indophenol blue and forms color that is measured. Chemiluminescence also can be used for determination. Benzene is another aromatic hydrocarbon compound which is a carcinogenic compound. Certain industries may during their operation use and emanate this benzene into the atmosphere, and we have only annual average. It is 5 microgram per meter cube in both residential as well as ecologically sensitive method area, and the method used for determination is GC, gas chromatography, based on continuous analysis of this benzene, or adsorption and desorption followed by GC analysis. We can use adsorption like activated carbon, in which benzene will be adsorbed and then bring it to the laboratory and desorb it and do it with a GC containing FID, flame ionization detector, is used for determination of benzene, or GCMS, advanced GCMS also can be used for determination of benzene in ambient air. Other important pollutant is benzpyrene. As I mentioned before, it is formed as a pyrosynthesis, the engine or any burning. It is possible to get this benzopyrene, which is highly carcinogenic, similar to benzene. And also we have annual average standard. See the value, it is 1 nanogram per meter cube. Okay, very toxic. The values itself indicate how toxic they are. The method used for determination of benzpyrene is gas chromatography or HPLC can be used. Usually the dust collected is extracted with a solvent extraction, followed by injection into gas chromatograph or high performance liquid chromatograph with a suitable detector can be used for determining benzpyrene compound, but the value is very low. So these pollutants are not routinely monitored. Wherever issues are there, okay, some contamination, some suspected thing, then definitely these type of pollutants like benzpyrene, benzene, ammonia, ozone can be monitored. The air particulate matters is also monitored for heavy metal contents in air, and in our Indian standard we have 3 elements, namely lead, arsenic and nickel. These are the parameters controlled, especially arsenic and nickel. We have only annual average. For arsenic, the value should not exceed 6 nanogram per meter cube both the places, whereas nickel 20 nanogram per meter cube in both the places, and lead we have annual average as well as 24 hours. 24 average is 1 microgram per meter cube, whereas annual average should not exceed 0.5 microgram per meter cube. So these are the standard for the highly toxic lead, arsenic and nickel. The method used for this determination of toxic metals are either we can go for AAS or ICP method, okay, by collecting the dust on the filter paper, and after digestion I will explain little something about this AAS or ICP. This is a destructive method. We have another method called EDOX, energy dispersive X-ray fluorescence, in which if the dust is collected directly on the Teflon filter paper, it can be exposed to this XRF and we can determine what are the elements present, lead, arsenic and nickel, and this is a non-destructive method. You can get back the sample and use it for further analysis if you want, whereas the AAS ICP method, the sample has to be digested or dissolved in a suitable acid and then do the determination with AAS or ICP. So, in the standard we have seen 2 things. One is the annual average or 24 hours or 8 hours or 1 hour monitoring, it is mentioned for the appropriate thing. The annual average, that is the arithmetic mean of minimum of 104 measurement in a year taken twice a week, 24 hourly uniform interval. This is the time frame used for to calculate the annual average value, whereas in the case of 24 hours or 8 hour or 1 hour monitored value of the respective pollutants is applicable, shall be complied with 98% of the time in a year, okay, should be complied with this standard. That is, only 2% of the time they may exceed the limit whatever allowed, but not on 2 consecutive days of monitoring. This has to be satisfied, otherwise it is viewed as the pollutants exceeded the concentration and there is something wrong with that location, and further investigation and control measures have to be employed. That is the indication. And just I want to mention, our Government of India is monitoring these type of pollutants, and especially SOx, NOx and particulate matter across the country through their respective state pollution control board, and now the National Green Tribunal has directed to monitor strictly, and some cities, especially in the particulate matter, exceeded the limit, whereas other pollutants, okay, sulfur dioxide, oxides of nitrogen, and this is paid attention, and even source apportionment study many state are conducting to find out what is the nature of the dust, whether it is comes from the because of the burning or some other thing, or because of natural things. More detailed investigations are going on, and to make control measure of this dust particulate matters. So, coming to this heavy metal, sources of heavy metal, if you consider why arsenic is considered in air, arsenic is one of the main contaminant wherever metals are smelted, like copper smelting is there, arsenic is likely to be present in this ore, and that is likely to come out. Similarly, coal combustion, that may also contain arsenic wherever these operations, that is metal smelting or coal combustion, that area has to be monitored for arsenic. Coming to lead, the sources of lead, why it is monitored? Combustion of fossil fuel, waste incineration, production of non-ferrous metal, production of iron and steel, production of cement, all these places there is a likely emission of lead. Okay. This has to be monitored. Earlier we used leaded petrol, and that was a issue, but it is eliminated now. Almost all the petrol station they eliminate this lead containing one, and its a issue is solved, but these places lead may be present. The next one is nickel is also monitored, and nickel may emanate from combustion of fuel oil and coal and thermal power station, combustion of fuel in ships, waste incineration, steel manufacturing, electroplating. Nickel plating is one of the things where nickel is likely to be emanated from the industry and may contaminate the surrounding air. Okay. So, we have standard for arsenic, lead and nickel even in ambient air quality. Our ambient air quality does not have standard for mercury, but this is one of the major contaminant in combustion of coal. So, all the thermal power station they have to monitor the coal which is likely to be emitted, even though it is not comes under the purview of national ambient air quality monitoring. So, in the standards all the values are given, you might have noticed, in microgram per meter cube. Okay. And sometime some of the analysis result may come in ppm or microgram per normal meter cube. Okay. So, the interconversion of ppm to microgram per meter cube or normal meter cube should be aware, so that it is easy for calculation. Okay. Whereas, in the case of water it is one and same, ppm and microgram per liter are one and same, whereas in air it is different, ppm is different from parts per million, is different from microgram meter cube. Why it is different? Let us see that example. I hope all of us are familiar with the Avogadro principle. As per the Avogadro principle, 1 mole gram weight of any gas occupying 22.4164 liter of volume at 0 degree Celsius, that is NTP, whereas at STP, that is at 25 degree Celsius or 298 Kelvin, the volume expansion takes place. So, the volume increase from 22.416 liter to 24.47 liter. So, there is a volume expansion is taking place. This has to be accounted in this conversion. So, ppm to microgram per meter cube, this has to be taken care. How this is can be solved? A simple equation is given here, that is ppm of the particular gaseous pollutant, that is milligram of the pollutant actually in microgram per meter cube, whatever it is measured, into this Avogadro's number, that is 24.47 liter. This is what it comes here, and divided by liter of air, how long that particular pollutant was taken for analysis of the pollutant, that is the milligram of pollutant present in how much of the air, into molecular weight of the substance we use it, you can easily convert this ppm into milligram per pollutant of the liter of the air. Okay. Let us see in a small example with the sulfur dioxide. Sulfur dioxide, sulfur 32 into oxygen molecular weight is atomic weight is 16, 2 molecules are present. So, 64 gram per mole is the one molecular weight of the sulfur dioxide. Will occupy 64 gram of sulfur dioxide will occupy a volume of 24,470 ml volume as per the Avogadro's principle at STP, standard temperature, that is 25 degrees Celsius. And suppose we want to express 1 ppm, that is equivalent to 1 ml per normal meter cube, is given by this 64, that is a molecular weight divided by the atomic the volume into milligram per meter cube, that is equivalent to 2.615 milligram per normal meter cube, or that is equivalent to 2615 microgram per meter cube of sulfur dioxide. Okay. So, using this Avogadro's principle, we can convert this ppm into milligram of the pollutant per air. Both are different, and the contribution or difference comes because of the volume expansion at higher temperature, that is 25. For example, nitrogen dioxide in a coal powered plant have a concentration of 650 milligram per meter cube. Suppose we want to express this concentration in ppm by volume using the above concept. If you look at it, nitrogen dioxide molecular weight is 46. If you use the above formula, the answer will come to 338 ppm by volume. As shown here, you put this value and molecular weight, and definitely you can arrive this concentrations, that is 650 milligram per meter cube of nitrogen dioxide is equivalent to 338 ppm of nitrogen dioxide. So, these calculations are very important. For all the gaseous pollutant, using this formula you can find out ppm or what are the milligram of the pollutant, but this is not applicable for particulate matter, because it is as we discussed, no molecular weight, it consists of different constituents, maybe inorganic, organic, mixture of all these things. So, this is only applicable for gaseous pollutant with a known molecular weight. The determination of heavy metal in particulate matter is very important one. We can use high volume sampler, diagram is shown here, collect the particulate matter, and after dissolution using atomic absorption spectrophotometer or ICP can be used for determination, or direct method with a Teflon X-ray fluorescence energy dispositive can be used to measure this. The dust collected diagram is shown. This is before dust collection. After dust collection, it will appear like this, and we have to dissolve for the determination of heavy metal with a appropriate acid and process it and use it. Usually Soxhlet apparatus are used with a simple one as shown here. Extract with the nitric acid, all the metals present in the oxide form are dissolved in nitric acid, and this acid you can use it for determination of extracted one, use it for AAS or ICP AES for its measurement. The modern quick microwave digestion also can be used for determination or acid dissolution, it is very quick. Also ultrasonation can be used for determination extraction and followed by determination using AAS or atomic emission can be used. And these technique also can be used for benzene and benzpyrene using the ultrasonation extraction of the appropriate organic solvent, and it can be enriched in a rotary evaporator with a smaller volume and then injected into GC or HPLC for the estimation of benzene or benzpyrene in air. Depending on the various standard given in, and suppose values are not complying to the standard, one has to think about the issue of air pollution. Something is wrong in that area, and we have to take control measure to control the air pollution. And generally, if you look at it, the use of alternate energy source is a one which control air pollution. Not only this gaseous pollutants like sulfur dioxide and oxides of nitrogen particulate matter, it also minimize the emission of carbon dioxide or completely eliminate carbon dioxide. So, global warming issue also can be stopped, suppose we switch over to a renewable source of energy like solar, wind, etc. Still, if you use combustion, a removal of the pollutants from the particular combustion product is very, very important, essential. Or we can go for the efficiency improvement of the combustion system, energy conservation can be used for this, or to minimize especially vehicular pollution, we can switch over to CNG, compressed natural gas, or electric car powered by solar one can minimize all this important emission of this pollutant. Especially industrial exhaust is a major contributor apart from transport sector, in which in the industrial sector they have to control the pollution. If it is a particulate matter, electrostatic precipitator can be used, or filter, back filter can be used for to minimize this. If it is a gaseous pollutant, they have to go for scrubbing with a suitable alkali solution or something for sulfur dioxide, oxides of nitrogen. Especially desulfurization, very, very important, in which lime is used and sulfur dioxide is converted into gypsum is a process. So, it is very, very important to control the pollutant if any environmental issue is not met as per the national air quality standards. So, to sum up, in this series of lecture air pollution standard we have discussed, and various standard depending on the residential area or ecologically sensitive area standards we have seen, and the method of measurement, and ultimately how to control these air pollutant in a very brief way we have discussed. So, with this we are completing the series of lectures on atmospheric chemistry. Thank you.